Are you talking something?
Yeah, good afternoon to all of you.
Good afternoon.
Okay, is my voice audible to all of you?
Yes, sir.
Where are the others? They have not yet joined.
I think they're coming.
Okay, just remind them.
Good evening, sir.
Very good evening. How are you?
Fine, sir. Kongwell is playing. What is that? Aim blocks. Kongwell, I saw you play aim blocks there. Hello.
Yes, others have joined or not? Just remind them.
One more.
Kongu.
Yeah, hello. You can hear me,
Yes.
Yeah,
right?
so shall we start? Is the screen visible to all of you?
Yes.
No, sir. Oh, okay.
It is visible, sir.
It is, it is.
I saw you play aim blocks there. You were playing aim blocks till now.
Now what?
When?
Yeah.
Yeah, now before.
Right now. Yeah, I killed you also
Huh?
once.
What?
Yeah, I was there in the game with you.
Okay, stop.
Is my screen visible to all of you now?
Yes.
Yes, sir.
Okay, so let us today discuss let us solve various problems, the questions of practice, right?
Yes, sir.
Yes, sir.
So first of all, I will
Yes.
just write a reaction and you have to tell me that what type of reaction it is.
Yes, sir.
Okay, yeah, sure.
Sir, how come the sums you give in
Let's
class
write it
are
one.
way? How come the sums you give in class are way easier than the sums in the worksheet, sir?
Yes.
No, sir. Like, how come the sums you give in class are like the sums you give in?
Question, sir.
It's sir. It was easy, but it was like
Hard.
very tough. Yeah, it is. No, it is tougher than the ones you give in class, sir.
No problem. That is why I am today solving a lot of questions so that you will face exam easily, so that all the questions they will be easy. Actually, you have to. Actually, questions are nowadays asked application based, and also the value based questions. So actually, you have to use your mind that if this is the question, then how you
Yes.
can write the appropriate answer. Yeah, exactly. So let's solve today various questions. I will just give some equations you have to tell me what type of chemical reactions they are, isn't it?
Yes, sir. Yes,
Exactly. Okay, so let's start. So I was just saying that, is this visible to screen to all of you, board?
Yes, sir.
Yes, sir.
Okay, so if I will just write a reaction like this, that is your N2O5. If I'm just heating it, it will get converted to nitrogen dioxide, and we will also get the byproduct as oxygen gas. So
Thermal
first let's balance.
decomposition, sir.
So first let's balance this.
Yes, sir.
So 5O2, 5 by 2O2, and then no.
Sir, you have to keep
5 by
2 at the 2 NO plus you have to put the wait.
2 and
So is it
so this will
balanced?
be 4
No,
plus
sir,
2
it's
will
not
be,
balanced.
Exactly. So
No, sir.
how to balance?
This side will be 8, that side will be 5, sir.
So what
So I
we will
think there should be 2 N2
8 by 5.
Sir, there's 5 on this side, there's 2 on that side, there's 4 on that side. So 5 and 4 don't balance. First, you have to balance the nitrogen.
So see, we
So-
will just twice here, and if I will write 4 times here, so it's now balanced.
So it'll be
Balanced.
Yeah, it is now balanced. You can check it out,
Oh yeah.
Oh
Okay.
yeah, yes, sir, yes, sir.
isn't it? Yeah.
Yes, sir.
It's thermal
Okay. Now,
decomposition.
yeah. So what type of reaction it seems to be?
Sir, it's a thermal decomposition, sir. 100%.
Exactly. It is your thermal decomposition. So that means you are now aware about this. So this is definitely your thermal decomposition, right? So can you tell me, is this thermal decomposition reaction reversible or irreversible? What do you think?
Sir, it is irreversible.
Exactly. So you will remember that this thermal decomposition reaction, it is irreversible. It cannot be
Always.
reversed.
Reversed.
Is irreversible. Then what is the difference between this thermal decomposition and the thermal dissociation? So another is actually the thermal dissociation. So I will write it here. Another is okay, I will write first the reaction. For example,
Sir,
if it is this,
thermal decomposition is irreversible and thermal dissociation is reversible.
Yes, sir.
Yes, sir.
That's the only difference.
Thermal dissociation.
Far as I
Yes,
know.
yeah. So for example, if it is just like this, I'm heating this calcium carbonate, isn't it? So it will just give you calcium oxide and the carbon dioxide, right?
It's reversible.
Yes, sir.
Yes. So this reaction is not the thermal decomposition. This is your
It's
thermal
a thermal
dissociation.
dissociation.
It's a full
Exactly. So that
Sir.
means you have to remember that thermal decomposition, that is irreversible, and thermal dissociation, it is reversible, right?
Yes, sir.
Yes, sir.
Exactly. So that means, for example, if you can reverse this reaction by writing like this, that if you are having this calcium oxide and you just react it with the carbon dioxide,
Carbon dioxide.
you will get again the calcium
calcium
carbonate.
carbonate.
Sir, we
Exactly.
only if we do on cooling it, sir.
Yes.
Yeah, same thing.
Yeah, cooling on it.
Cooling.
Cooling.
But it's
Exactly. See, simply that calcium oxide, it can easily react with this carbon dioxide and it forms back again the calcium carbonate. So hence it is reversible. Yeah, we are cooling here. Head. Yeah, exactly. So you have to remember that there is a difference between the thermal decomposition and the thermal dissociation. So thermal dissociation is just reversible, and thermal
reversible
decomposition.
thermal
Yes, irreversible.
Got it now?
Yes, sir.
decomposition, but reversible.
Sir,
Thermal.
sir, is there anything like N2O4?
Yeah, I will tell you. If I will write N2O4, it is yeah, definitely dinitrogen tetroxide. It is always in equilibrium with the nitrogen dioxide.
Sir, please don't use that green marker, so it hurts my eyes.
No problem. Okay, I will use the black one. So now tell me that this nitrogen N2O4, that is your dinitrogen tetraoxide. It is in equilibrium with this nitrogen dioxide. So they are both the oxides of nitrogen. So they always exist in equilibrium. So that means this N2O4, it gets converted to this nitrogen dioxide. And yeah, nitrogen dioxide molecules, they again combine to form
N2O5, you written right. So what is that? Dinitrogen penta oxide.
exactly. This one is, yeah, this is known as dinitrogen pentoxide, N2O5, and this is known as dinitrogen tetraoxide, and this is known as nitrogen dioxide. So they exist in equilibrium with each other, right?
Yes, sir.
Yeah, so you have to remember this, they exist in equilibrium. So have you written down this? Shall I rub it?
Sir,
So one
One
second,
second,
sir.
sir.
Okay, write down this.
I have written down.
Bad boy, don't listen to class.
Who?
If you ask me no, I can answer.
No, Nitish.
If you ask me no, I can answer.
Done, sir.
So wait, sir, I'm just writing N2O4.
Okay, write down.
Sir, like it's thermal equilibrium, right?
Yeah, exactly, it is the thermal equilibrium.
So one moment.
So you can go to next page. Are you ready?
Sir, done, sir.
Okay, so let's move to the next page. So now if I will just write an equation that's very important, that is like this, that I'm having iron sulfate, that is FeSO4. It reacts with sodium hydroxide, that is your NaOH. It is a base. So what it will form, it just forms
So 4 and iron hydroxide.
iron hydroxide, exactly, that is
Sodium
uh,
sulfate.
and it will definitely form the sodium sulfate. Okay, now can you
Sodium,
balance this?
yeah.
Can you balance
So
this?
2 NaOH.
So I have to put two NaOH.
2
yes.
NaOH. That's it.
Yes.
Yeah, I said this.
Okay, 2 NaOH.
That's it, sir.
It is now balanced, right?
Yes, sir.
Yes, sir.
Tell
it
me
is.
that this FeOH whole twice. This is your, it is having dirty green color. So I will write it here that it's
Yes, sir. You
having
said, sir. I remember.
dirty green PPT. PPT means
So
precipitate,
what's the
right?
difference between So what's the difference between dirty green and dark green?
Yes, dirty means which
They
will
both
not
are-
be pure green. So whenever we have green color, if there is some, let's say the dust particles, so that will not seem to be the clear. So that which is not clear, so that's your dirty green.
It's not like pure green. It'll have some impurities mixed with it.
Exactly. It is not pure green. So now see how question will be asked. Question will be asked that write a reaction in which there is formation of dirty green PPT. So you have to remember this reaction. This is very important. And sometimes it will be asked that which type of reaction it is. So can you tell me which reaction it is? Is it
It's a double
combination?
dissociation reaction. Double
It's a
D.
precipitation reaction.
So it's a double
Yeah. First of all, it is a
reaction, right?
precipitation reaction, right? Precipitation
Yes,
reaction.
sir.
It's a double displacement.
And
Yeah,
it is
double
also
displacement. Double displacement.
double displacement reaction, right?
Yes, sir.
Yes.
Double displacement reaction. So I hope you can remember
hear
this,
me?
right? Yeah.
Yes, sir.
Okay.
So write down this, that this question will be asked. It's very important that you have to write such an equation in which there is formation of dirty green PPT. So you have to remember that when iron sulfate, it reacts actually with this sodium hydroxide, then it forms this FeOH whole twice. That is actually your ferrous hydroxide. So this ferrous hydroxide, it is having dirty green color.
Done, sir.
Yes,
So
sir.
what is
Done,
the-
sir.
Okay, what is the name of this FeOH whole twice? It is your ferrous hydroxide,
Ferrous
right?
Ferrous
hydroxide.
hydroxide.
Ferrous hydroxide. Very clear.
Yeah, it is not the ferric hydroxide, it is your ferrous hydroxide.
Ferric is
Is
53,
that-
sir.
Yeah.
Exactly. So can any one of you tell me what will be the formula of ferric hydroxide?
FeOH
So
whole
FeOH
twice.
whole 3. Yeah.
Exactly.
Sir, if you want
That-
whole thrice.
Whole thrice, exactly.
Yeah, everything same. Whole thrice, whole 3.
No, it's
Yeah.
whole thrice only. Whole 3
Yeah,
means
see,
there
sir
is
said,
no-
yeah.
Better is to call it as whole thrice. So it is FeOH whole thrice. So it is your ferric hydroxide. Okay, so then let me write another equation and you have to tell me what type of reaction it is. So if I will
You have to
just,
balance it, right?
it's already balanced, isn't it?
No, sir, not this one, sir. The next one. The one you're gonna write now.
Okay, I will write first. So it is your sodium sulfate. It reacts with barium chloride. So what will be the product? Can you tell me here the product? Product will,
So NaCl2
Sir,
plus
NaCl
barium sulfate plus
Sir,
sodium chloride.
barium
barium sulfate.
BaSO4
Okay.
twice.
Okay,
BaSO4
now-
twice.
First.
So can you balance this now?
Oh, it's balanced. okay.
Sorry, no, 2 NaCl, that's it.
So 2 NaCl.
Exactly. I will write twice NaCl.
When I say
So
You say-
now tell me
Say-
what type of reaction it is.
So it's a double displacement reaction and it's a redox reaction.
Exactly, it is a double displacement.
redox reaction.
It is a
Double
redox.
double displacement reaction. Double displacement reaction it is. It is very easy and clear. Now you are saying that is it a redox reaction? So the answer
It's a
is no.
It is a
It
redox.
is not a redox reaction.
Oh yeah.
Oh.
It's not.
Oh my god. Help, Sankar.
Sir, but you said every reaction is a redox reaction. Oh.
That's all.
Yeah, that is, yeah,
Or-
most of the
or-
reactions
sir,
they
wait,
are your
electrons
redox reaction, but
there,
this is
no,
not.
sir.
It is not a
There
redox.
electron exchanging, no, sir.
Yes.
Yeah. So
Sir,
yeah.
but sodium gets reduced, right, sir? It gets oxygen gets removed.
But there is also addition of chlorine. No, see, actually here sodium, it is having +1 valency here, +1 charge oxidation state here. It's also having +1, so it is not getting oxidized, neither it is getting reduced.
Okay,
This
so
is
yeah.
actually the higher concept.
Exchanging electrons is there, right, sir?
See, actually
Sir,
you
that means our school chemistry teacher lied to us, sir. She said all the reactions are redox reactions.
no, it is not necessary that all the reactions will be your redox reaction. So this is not a redox reaction. See how I will tell you. You have just now studied only the one of the definition of oxidation and reduction. It is actually having 3 or 4 definitions. One, the definition which you have studied, that is addition of oxygen or the removal of hydrogen, that is oxidation. But another is the electronic concept. In electronic concept we say that when there is loss of electron, so that is the
Or
oxidation. And when there is
Gain of electrons redox.
Exactly. But another concept is the oxidation state. Here in case of this sodium, what is the oxidation state? I will just write it here that for yeah, exactly the oxidation state here, it is the +1, and here it is also the +1. So there is no, yeah, so that means there is no change in the oxidation state. So neither it has gone oxidation nor reduction. Similarly, barium, it is having here the oxidation state +2, and here also in the barium sulfate it is +2. So there is no increase or decrease. So there is no oxidation or reduction. This is very important. I hope you will remember that it is not a redox reaction. Got it?
Yes, sir.
Exactly.
Yes.
Okay, now let me write another equation and you have to tell me what type of reaction it is.
The iron is here or the 2 plus. On the other side also it's 2 plus. In this side the sodium is 1 plus. In that side also it's 1 plus. So this is also not a redox reaction.
Exactly.
Exactly. Yeah.
Okay, now tell me that if I will write H2 hydrogen with oxygen, so what it will form?
So water, H2O.
Okay, can you
It's
balance this?
a
So
synthesis
into
reaction.
Yes, sir. Just two. Sir.
Exactly. What type of
H2
reaction
and
it
2
is?
at H2O. Sir,
Synthesis
it's a synthesis
reaction.
reaction.
Exactly, it is a
And the
synthesis
redox
reaction.
reaction.
Exactly, it is a synthesis reaction and it is also your redox reaction.
Yes.
So because
Sir,
here actually,
So will you ask the color of the precipitate in the exam?
yes,
Dark
exactly.
dirty
It is asked. Yes, I just told you that this is having dirty green color, so this will be asked in the exam. This is very important. It is asked.
So
Yeah,
will you ask name the dirty green precipitate reaction? We have to write the whole thing. Or will you ask
exactly.
dirty green precipitate and we
Yeah,
just write
See,
FeOH twice?
see, question will be asked like this: that write a chemical equation in which there is formation of dirty green PPT. So you have to remember this whole equation and you have to write the whole
Or they
equation there.
ask just to write the dirty green precipitate. But just
Then
we
you
write
have to only,
FeOH
yeah,
twice.
then you have to only write ferrous hydroxide, that is FeOH whole twice.
Yes.
Got it now? So this is a synthesis
sir.
reaction and it is also a redox reaction, correct?
Yes.
Okay. Now, can you tell me what type of this reaction it is? If I will write, okay, let me write here with the black color. So this is my iron sulfate, that is FeSO4. Okay, let's say it is my iron and I'm reacting it with copper sulfate. So what will be the product? So what will be the product?
So
So
copper,
it will be
see,
FeSO4
copper
plus copper.
iron sulfate.
FeSO4 plus copper.
So what type
Oh,
of
I
reaction
said
it is?
So it's a displacement
So
reaction.
it's a double displacement reaction.
It's under redox
It's a
reaction.
displacement rate. So
It's
can
not
you
a
now
redox reaction.
can you tell
So
me
wait,
that can you tell me are
okay.
these displacement reactions endothermic or exothermic?
So this is endothermic. No, wait,
Exothermic.
exothermic.
I am just
So
saying that
Pongal
if
says
you
he
have
can't
any
hear you, sir.
displacement reaction, will it be endothermic or exothermic? What do you think? Displacement reactions, they are always exothermic. So will you remember it?
Yes,
So
sir.
Kongwell says that he can't hear you, sir.
But why? Are you able to hear me?
He left. He said he'll rejoin.
Maybe he is having some mic problem issue there, but mine side is okay. So is my voice now clear to all of you?
Yes, sir. Yes, sir.
Okay. So
Sir,
now
even double displacement is also always exothermic.
no, that is not necessary that double displacement will be always exothermic, but displacement reactions, they are exothermic.
Okay, sir.
Okay, so have you write down? Shall I rub it?
Yes, sir.
So
Hey, turn on your video. Sir.
Shall I move to the next page?
Yes, sir.
Yes, sir.
Okay, so now let me write here an equation, that is this one, calcium hydroxide, that is CaOH whole twice. It reacts with ammonium chloride, that is NH4Cl. So what it will form?
Calcium chloride plus ammonium hydroxide.
Yeah, it will form calcium
So
chloride
it's a
plus
double displacement reaction.
ammonium hydroxide.
It's
So you had
exothermic reaction. It's not an exothermic reaction. Sorry, sir.
so which reaction it is?
double displacement,
It's
sir.
Yes, sir, I said it first.
Yeah. Now there is question for you that can I write it as that it is a double decomposition reaction?
No, sir, you can't, sir.
Why can't I say that it is a double decomposition?
Oh, wait, okay, you can say
Sir,
that.
but sir,
Yeah, it is
you can't
decom-
because the sir, but
Why? Tell me.
there's okay.
I think it
Sorry.
can be both.
See what you have to remember. It was calcium hydroxide. Now it is here calcium chloride. So that means it has got decomposed. And similarly, this ammonium chloride, it has got converted to ammonium hydroxide. So that means first of all, these two compounds, they have actually decomposed. So this is a double decomposition reaction also. Got
Sir,
it?
sodium is not even in the reactivity series. That's right.
Yeah, it is ammonia here. It is not the sodium NH4.
It is NH4, sir, ammonium.
Yeah, it is the ammonium chloride, exactly. So it
Sodium,
is your double decomposition reaction, right?
yes, sir.
So is that
Exactly.
because ammonium is not even there in the reactivity series?
Yes.
Ammonium is not there in the reactivity series, right?
Yeah, exactly. Ammonium is not there. And see actually what happens when we just heat this ammonium hydroxide a little bit, it gets converted to ammonia and we get the water. So that's why it is decomposing. So that's why it is your double decomposition reaction. Okay, now you have to tell me, okay, there are few questions that you have to tell me the formula of sodium bisulfate.
Sodium bisulfate.
Okay.
Sir,
Yeah.
NaHCO,
Sir,
NaHCO,
and
oh, bisulfate,
sir,
NaHCO4.
NaH2SO, NaH2SO4, sir.
NaH2O4, sir, that's it.
H.
So will it be Na? Okay, I will give you the options. Sodium bisulfate. So one is
Sir,
your
NaH2SO4. Na2.
You said H2.
I said H2SO4.
It's not H2SO4, it's HSO4.
it is sodium sulfate.
Yeah, check.
Oh, sorry.
Okay.
Sir, none of these options are correct, sir. Yet. No,
Yes, HSO4.
Yeah, exactly. So this will be the correct formula. So that is NaHSO4. Got
So
it?
this was the question I asked you, sir, in the exam.
Exactly. So that means
And
you
you
have
got
to
it
remember
wrong.
that whenever there is HSO4, that is the bisulfate ion. For example, if yeah, exactly. HSO4
New element in this valency charts.
it is known as bisulfate ion. Got it?
Bisulfate, bisulfite, bicarbonate.
Exactly. Similarly, if I will write
HSO3.
just HCO3 negative, so what is this?
Carbonate.
The bicarbonate.
It is yeah, exactly the bicarbonate.
HSO3 minus.
Yeah,
T is
HSO3.
bisulfite.
Exactly.
Bisulfate. Sorry, bisulfite.
Bisulfite.
So now can you tell me the formula of magnesium nitride?
MgNO3 twice.
So what's the
Magnesium
That is the
nitride.
answer. MgNO2 twice.
So can you tell me the formula of this magnesium nitride?
No, nitride. Sir. Mg.
Yeah, it is nitride.
Mg3NO2, sir. Mg3NO2.
No, you're wrong. Mg3N twice. No, 2. Mg.
Yeah, that's what
N2. You said N2.
Exactly.
said.
You said
Exactly. This will
NO2.
be correct. So it will be Mg3N2. That is magnesium nitride, correct?
Yes, sir.
Okay, then can you tell me the formula of magnesium nitrate?
Mg.
Magnesium nitrate. It is NiTrate.
MgNO3 twice.
Yeah, it will be MgNO3 whole twice, right?
Yes, sir.
Yes, sir.
Exactly.
You took your book and came out.
No, I went to drink some water and come.
So can you tell me the formula of ammonium nitrate?
So NH4, NO3, that's it, sir. NH4, NO3.
So ammonium nitrite.
Ammonium
NH4,
nitrate.
NO3, sir.
So
NH4, NO3.
NH4NO. NH4
Exactly. It will be NH4NO3.
Yes, sir.
Exactly. Ammonium
So
nitrate.
I
Got
get
it?
confused with nitrate and nitrite, sir.
No confusion. I will tell you.
Nitrite and
If
nitrite.
if it is NO3 negative ion, so that is your nitrate ion, right?
Sir.
If it's NO2, it's nitrite.
Yeah. If it is NO2 negative ion, so that is your
If
nitrite.
it's N3 minus, if it's nitride.
And if it is N3 minus, exactly, that is your nitride. That is IDE.
Nitrogen.
Are you getting?
Nitrite.
So nitride is nitrogen, right, sir?
Exactly. Simply, it is nitrogen. Got it now?
Yes, sir.
So write down this, then we will move to the next.
So 1 second, sir.
What about some formulas with variable valency? Can you hear me? Can you hear
So
me?
have you written down now?
Yes, sir. Sir, can you give us
Sir.
some formulas with variable valency, sir?
Exactly, I will give you. Sure.
Congo still didn't join.
Yes, sir.
Okay. Shall we move to the next page?
Yes, sir.
Okay.
So Congo is not even online, sir.
Why? Where is
Why would
he?
be online, right, sir? In class.
No, I'm talking about Discord online.
Why will it be online in Discord?
Dave, his computer is on, he will be online there.
No, if you open Discord, it'll be on.
Hey, that guy never closes Discord there.
Let's see about it. So you can continue, sir.
Okay, now tell me, you were just saying that formula of variable valency. For example, iron shows you variable valency. It can show you
2 and
plus
3.
2 and
Two
yeah,
and
2 and
three.
3. It's just FeCl2 and FeCl3. So can you name these? What is FeCl2?
Some ferrous
So
or ferrous chloride.
ferrous chloride, ferric
So
chloride,
ferrous.
sir.
Exactly.
so
This
ferrous
will
chloride,
be
ferric
your ferrous
Chloride.
chloride, and this will be your ferric chloride, right?
Yes, sir.
Yeah. So similarly, you are having tin that also shows the variable valency. For example, tin, it forms SnCl2 and SnCl4. So what
Yes,
is
sir.
this SnCl2? SnCl2 is your stannous chloride. Stannous chloride, and SnCl4, it is your stannic chloride.
So why do these elements show variable valency, sir?
Yeah, it shows variable valency because it has actually, it depends on the number of valence electron and the inert pair effect, which you will study in the higher classes. Inert pair effect, that is not in your syllabus.
So Sn is tin, right?
Sn is tin, yeah, exactly. But its Latin name is stannum. That is why we are writing stannous chloride and stannic chloride. If I will write just a CuCl2, what is this?
So
So
copper
copper
chloride.
chloride.
No, it is cupric
No,
chloride.
cuprous chloride. Oh, cuprous chloride,
Oh,
sir.
shit.
No, it is
Oh,
cupric chloride.
Okay. Sorry.
If I will write Cu2Cl2, then this is known as cuprous chloride.
Cuprous. I
Exactly.
forgot it has variable valency 1 and 2.
Yeah, this is the variable valency. You had to remember it.
So I forgot the variable valency chart entirely.
No problem. Just remember here. If it is AuCl, it is known as
The silver
Aurus.
chloride.
It is known as
Oh,
yeah,
Aurus
Aurus
chloride.
chloride. Auric
Au is the
chloride.
symbol of gold. Au is the symbol of gold. So if I will
Yes,
write
sir.
AuCl3, is known as
Auric.
exactly auric chloride.
Oh, I was right.
Exactly. Just try down.
Yes, sir, done,
So
sir.
gold shows variable valency 1 and 3.
Exactly 1 and 3. You can understood it easily. See here it is only one chlorine, so that means gold shows one valency here, and here are the 3 chlorine atoms, so the valency is 3 here. So that means it
Yes.
shows variable valency 1 and 3.
Finished writing, sir.
Okay, now
Yes,
tell me
sir.
what is this Hg2Cl2 and what is HgCl2?
First one is mercury
The aluminium. Ha.
oxide. Oh yeah,
Yeah. Aluminium.
mercury.
Mercury, ma'am.
Mercury.
It is the
So what
I
do you
got
mean,
it.
Ra?
I don't know.
Mercurous chloride and
It's
mercury
mercurous chloride and this one will be mercuric chloride.
So why did we
Exactly.
write it as Hg2Cl2? So you can just write it like HgCl, right? Sir?
Yeah, it exists like this. That is why it is Hg2Cl2.
Oh.
Just as we write, what is the formula of hydrogen peroxide?
So hydrogen. Hydrogen.
Peroxide. Hydrogen peroxide.
HO5.
No, that is H2O2, hydrogen peroxide. So it is same Hg2Cl2. That is your
I thought it was
mercurous chloride.
pentoxide.
If I write Hg2O2, it is mercurous peroxide.
Yes, exactly. But that does not exist. If we will just write Na2O2, that is your sodium peroxide, it exists.
Yes, sir.
Oh, peroxide
Nope.
or peroxide.
Yeah, it is the sodium peroxide. So I hope you will remember it. So just write down these.
Yes, sir, done, sir.
Okay, so shall I move to the next page? Shall I move to the next page?
Yes, sir. Yes, sir. You can go to the next page.
Okay, so then let's solve a question on the percentage composition. I hope you remember the percentage composition, right?
Yes, sir. Yes, sir.
So can you tell me the percentage composition of carbon in carbon dioxide?
Yes, sir. I can.
Okay, just calculate here.
Yes, sir.
So carbon dioxide, what is it is molecular mass?
Sir, don't tell, sir. Don't tell, sir.
The
We do it, we do
carbon,
it.
it is. Oh, I shouldn't say.
It's 44 gram,
Yes.
isn't it, per mole? Okay,
Yes,
now
sir.
tell me how to calculate the mass
The 44
percentage.
12 by
divided
100
by
into
no
44.
12 divided for carbon.
Yeah,
it should
12
be
divided by
44
100 into 44.
100.
Exactly, 12 upon
yeah.
44 into 1000, right?
12 upon
Sir, 100, sir.
44.
Yeah, into 100, exactly. So can you tell me the answer? What will be the answer?
27.27, sir.
Sir, 20. Sorry, yeah, 27. 27.
27 point
27.
27.
Yeah,
So it's
27.27.
actually recurring. It's
So
like 27
oxygen.
comes on, but okay.
Yes, sir. So oxygen is 73.7272.
Yeah, exactly, nearly it will be that. So now question will be asked like this. Question will be asked like this. that you have to calculate. Okay, I will write the question. Calculate mass percentage of water in crystals of washing soda. So do you know what is washing soda?
Yes, sir, I remember, sir.
Can you tell the formula of washing soda?
So wait, I remember.
Okay, I will tell you.
CO3 dot
Washing
Don't
soda.
remember, sir.
Okay, tell me.
Na2CO3 dot, I forgot, sir.
Okay, no problem. It is
H2O.
Na2CO3 into 10 times water. This is known as washing soda.
Chow. When water.
Sodium,
Oh, okay.
it is actually sodium carbonate decahydrate. Deca means 10. So there are 10 water molecules. So it is sodium carbonate decahydrate. It is known as washing soda. Can you solve this question?
So hydrogen is one, right? Hydrogen is one, right?
It is actually 10 times water, H2O.
Sir, in that hydrogen is one, right?
What? Yeah, mass of hydrogen is 1.
So,
Exactly.
Yes.
Oh,
No,
mass.
like one hydrogen is.
Okay.
Okay, first tell me the molecular mass
So
of
180,
this.
sir.
washing soda.
Sir, 180, sir. 180, sir.
What is the molecular mass of washing soda?
1 second, sir, I'm doing it, sir.
Yeah,
Percentage.
just calculate it.
Not
So
percentage,
sodium it is 23 into 2, carbon it is 12, and oxygen it is 16 into 3. Then it is actually water. What is the molecular mass of water? That is 18, right?
16.
18, sir.
Oh,
18,
water.
sir. It's 18.
Yeah. See, it is
Okay,
oxygen
water.
16, 16 and 2. That is
16 plus
18.
2, 18.
Exactly. 18 into 10. So what is that?
18 into 10,
180.
180.
Yeah, exactly, 180. Okay, now
180.
just follow this.
Doing it, sir. I'm doing the calculation. 286, sir.
Yeah, so how much it is coming?
286.
Sir, 402, sir.
286. No, 286.
Oh, sorry.
Sir, it's
286.
286. So for water, it is 6.2937.
Yeah, so what is the mass percentage of this water? Mass percentage of water you had calculated.
6.29370, sir.
So that means it will be 180 divided by 286 into 100, right?
180, how, sir? It's only H2O, sir. You shouldn't find 10 H2O, sir.
You have to calculate mass percentage of water, not hydrogen. You have to calculate the mass percentage of water. So
Sir,
water is this.
only, sir, but water is only 18, right, sir?
No. You have to check the total mass of water in this washing soda. That is 18 into 10 because there are 10 water molecules.
Hold that earlier, sir.
This is very important. There are 10 water molecules. For example, tell me when you just calculated the mass per. Just tell me when you calculated the mass percentage of oxygen. What you wrote the mass of oxygen? Have you written down 16 or 32?
2, sir.
Exactly, 16 into 2. So that is why you will write here 18 into 10. So that is 180.
So I'm getting 1.55555555.
No,
Yes, whatever.
62.93706294.
Yeah, whatever the value comes here, that will be the mass percentage of water.
62.2, 62.
So I'm getting 1.55555555.
1.5.
Most of the things are. It's 62.937, sir.
62.93.
706.
Sir, you did for the entire water.
Yeah, you have to take it entire water. Exactly. You have to take the entire water here. That is 180.
18, right?
Because it is 18 into 10. Why you are neglecting this 10 here? It is 10 times water.
It wasn't part of the water.
You have to calculate the total mass percentage of water. So there are 10 water molecules here in this washing soda. Are you getting?
80 now. Yes,
Yes,
sir.
sir. Okay.
Yeah, this is very important that this
1.2.
should be in your mind that you will not just take only 18, you will just multiply it by 10. So 180 you have to take it. So is it confusion now clear?
Yes, sir.
Sir.
It is not
Yes, sir.
1.2, whatever you said, right? 6.2937, even if you take 18.
So I got the correct answer.
Okay, what is the correct answer now?
It's 62.937, like that is like that.
Okay, right.
Yes, sir. It
So-
goes like 62.937.
Almost endless.
Yeah.
Like that.
Sir, I'll
Okay,
just
now-
calculate it and check.
Now tell me, if question is asked that you have to calculate mass percentage of sodium in this washing soda, so how you will calculate?
Just put 46
Exactly, it is 46,
divided
not
by 286 into 100. Yes.
exactly.
16.039160
16
I'm
point.
calculating there.
083. You also doing the same, so shut up.
No, I'm not using calculator.
Liar.
I'm actually not using calculator. There.
You got 1.05 using your normal calculation. Okay. 16.08.
Actually, there.
Liar.
I'm not using calculator.
Okay.
So have
very
you written
normal,
down this?
okay.
Shall I move to the next page?
Yes, sir.
Yes, sir.
Okay. So let's see now that what is actually a catalyst. So have you heard this term? What is a catalyst?
So it speeds up the process.
So
of,
it increases
reaction
the
without
rate of
taking
reaction
part in
of.
the reaction.
Yes, sir.
Yeah. So I will write that any substance which changes the rate of reaction.
Yeah, that's what I said.
Of taking part in it.
Yes.
Any substance which changes the rate of reaction. It can increase the rate of reaction. It can also decrease the rate of reaction.
Increase the rate of reaction.
According
Exactly. Which changes the rate of reaction. So that is why we are saying that catalysts are of two types. One is the positive catalyst, another is the negative. So positive catalyst will always increase the rate of reaction. Are you getting?
Yes, sir.
I will write it here that positive catalyst increases the rate of reaction. Positive catalyst increases rate of reaction. Right? Now, can you give me the example of catalyst? For example, if I will write the Haber's process. Haber's process is just like this. N2 plus H2, it gives you the
N2
ammonia.
plus H2 gives NH3.
So can you tell me which catalyst here we are using?
So iron chloride.
No.
Yeah, we are just using the catalyst iron, Fe.
Oh, just iron. Okay. But I said iron.
Yeah.
So I was thinking.
Now, okay, just I will give a few more reactions. If it is FeClO3, that is your potassium chlorate. When we just heat it, we get the potassium chloride and the oxygen gas. Can you balance this reaction? So you will write
3 or
twice.
2 plus 3, 2 and then 3. Yes, sir.
Exactly. Now in this reaction, the catalyst used is manganese dioxide, that is MnO2.
Yes, sir.
So that means we
So
use
this is
different
potassium
catalysts.
chlorinate.
It is your potassium chlorate. I will write it here. It is your
Chlorate.
potassium. Yeah, this one is potassium chlorate. And this is
So
your
it
potassium
uses,
chloride.
So what is it? It uses permanganate for as a catalyst.
Potassium permanganate. Yeah, potassium chloride. We are here
my
using
God.
manganese.
Look who
Potassium
joined.
permanganate.
Hello?
It uses permanganate to as a catalyst. Sir.
We can hear
Hello,
you,
sir.
Dr.
Yes, we can use potassium permanganate also, but the main catalyst is
No,
manganese
sir.
dioxide.
Sir, sorry I
Sir,
left because my
ethanol
internet
itself is
re-
permanganate.
The catalyst in this
Hey,
reaction, it is manganese
Nitish.
dioxide. Just remember this. So let me write another reaction, that is
Wait
your
once, Kongal wants to speak with sir.
I didn't know you were speaking.
Sir, sorry sir, I left
No
because
problem.
my internet balance was over, sir.
But you should be aware about that you are taking class at 5:45. You should be having the internet pack.
Yes, sir. It came for the first 15 minutes and then it got over. My dad's not here, so I didn't know.
Okay, no problem. Just to focus now. So here we are just having this H2O2. Upon heating, it gives you H2 plus O2. Can you balance this?
Sir, you just have.
So it's
It is
already
already
balanced.
balanced, sir.
Yeah, it is already balanced. Now, can you tell me which catalyst is used here?
Iron fluoride.
No,
oxide.
it is the platinum is used here as catalyst. Platinum.
Sir, how do you memorize all this?
Yeah, actually, we are dealing with these reactions. We are just studying every day, so that's why we remember. Actually, see, this is your very important industrial process known as Haber's process. So we just study it in detail.
It's very popular. We
Haber,
study this.
yeah, it's very popular.
Yes,
So
sir,
that's
we
why
did
we remember.
Haber's
Right.
process, but what about
Similarly,
this?
on the text, it is also given this potassium chloride because here we prepare this salt, potassium chloride. So here the catalyst used is manganese dioxide. So you have to remember it. And similarly, if, for example, I will write a reaction like this, and this is my ethene, and I'm just reacting it with hydrogen. So it gives me, what will be the product here?
So,
Product will be your alcohol.
CH3, sir.
CH3 single bond CH3. So that's my ethane, right?
So CH3 dash CH3. What is dash, sir?
Dash is the single bond. It is actually the bond between the two carbon atoms. Here it is double dash. Double dash
ethane
means
is C2. Oh, CH3 dash CH3 same as
Yeah, I get it.
it is
C2H6.
now see here that it is CH2 double bond CH2. Double dash
So
here
you
means
you
double
taught
bond.
us few classes ago.
Yeah, exactly. So this is my ethene. It reacts with hydrogen. It forms this ethane. So first of all, remember that this is an addition reaction. So what type of reaction it is?
C2H6.
It's an addition reaction.
Or you can also say that it is a combination reaction. Is it right?
Yes, sir.
Yes,
Exactly.
it is.
Synthesis reaction.
Exactly, it is a synthesis reaction. Okay. Now, can you tell me, this reaction is very important. Which catalyst is used here?
No.
So nickel is used as a catalyst here. Nickel.
So why do they use completely random materials for as a catalyst?
Yes, sir.
Yes, because
Like
see,
once-
actually, okay, I will tell you the answer. Just focus. Catalyst is such a substance which will just increase the rate of reaction. Positive catalyst. So all the other substances, random substances, they will not increase the rate of reaction. That is why we have to use a particular substance which will just increase the rate of reaction. That's why
Yes, sir.
we are
But how do you like let's say I'm experimenting this reaction for the first time and I don't know
about
Yeah.
what will be the
Then you test every
characteristic of
single
this thing.
material. We hope
That
Yeah,
is
should
why.
we put every single material and try it out?
No.
we hope
You
this
have not to
building
put
doesn't
single
Hey,
material.
like
You
they'll
have
know this material won't rust. This material won't it's durable. This material is very
see here.
combine.
Don't speak all. I'm just saying that if you don't, you have to remember it because it is already experimented. It has already been found that nickel acts here as a catalyst. So you have to remember it. If there is some new reaction, and then you have to try, yeah, any substance, any other material which will just act as a catalyst. But if there is already a research paper published in which it is already told that nickel acts as a catalyst, so you have to remember it. There is no any other
Sir,
option.
that
do
people
they
that people use faith as their materials. They tried every single material, hoping it doesn't explode the entire building.
Yeah, whenever we do research, so that means we are experimenting there. We can use different substances to check out that
No,
which
sir,
will act as a
like,
Isn't it like
No,
dangerous?
Nitish, stop it there. Let me talk. You've been talking all this time. Sir, I mean like,
Okay,
do
tell.
they use every single element in experimenting? Like they put every single element into
No, no, no,
CH2 double.
no, no, no.
Only
They are
metal.
not just now. Let me speak. They are not using each and every element. They are just using those elements which will have the capacity to act as a catalyst. For example, they
Yes.
are using. Now tell me, this iron, this manganese, this nickel, this platinum, they are all your D block elements. So D block elements, they act as catalysts.
Okay, sir.
Yeah, not
Yes, sir.
all the
That
elements.
was our doubt, sir. That was our doubt.
Okay, no problem. You can ask the doubters, but don't speak all at a time, single time. So have you written down this?
Yes, sir.
So now can you repeat it again? What is a catalyst?
So catalyst is a D block element where the substance changes the rate of reaction without taking part of
Yes,
the
catalyst
reaction.
is any substance which just changes the rate of reaction. But if we are now, catalysts are of two types. One is the positive, another is the negative. Positive catalyst, it always increases the rate of reaction, right?
Yes, sir.
Yes, sir. Negative.
And
Just
negative,
opposite.
can you tell me what will negative catalyst to do then?
It will decrease the rate of reaction.
Exactly. Negative catalyst will always decrease the rate of reaction. So, but most of the catalysts, they are your positive catalysts. So that means they will increase the rate of reaction. Got it?
Sir.
Yes, sir.
Is it
So,
now clear to all of?
Yes, sir.
Yeah.
So isn't it very expensive to just add platinum into H2 plus O2, sir?
Exactly. Platinum, it is a definitely, it is, yeah, it is not very much cheap. Platinum, palladium, they are highly expensive. So, but whenever we have to prepare this hydrogen and oxygen from this hydrogen peroxide, we use here the platinum as a catalyst. Got
But I
it?
feel like it's just a bit too not worth it, sir, because you use platinum just to separate hydrogen and
Yeah, this
oxygen.
platinum and palladium, it is also used in the fuel cell when we prepare water from hydrogen and oxygen gas. They are expensive. That's why fuel cells are also expensive.
Yes, sir.
You need what to separate the water is.
Yes.
What? No, sir, like we can even get hydrogen and oxygen even without including platinum, right? So platinum is just a catalyst which increase the rates of reaction, right, sir?
Yeah, we can get, but if we
Get
have to
like
increase
one
the rate of
star.
reaction, and if we just have to increase the rate of reaction, and if we want this hydrogen and oxygen gas in a maximum yield in short period of time, then we use this catalyst, right?
It'll take like months for it to separate without the catalyst, right?
Yeah, it is very, see, I will just tell you. Okay, have you written down this?
Yes, sir.
Sir.
For example, if I have to prepare water, if you are just going to prepare water from hydrogen and oxygen, if you will just mix these two gases in the lab, you will not get water, even if it takes 2 or 3 years.
Fuse
So
it.
that is why we are using here the
It's
catalyst
heat and
platinum.
pressure, sir.
Exactly, we are using the pressure. We are also using these catalysts. Then it is possible to convert this hydrogen oxygen into water. Got it?
Yes, sir.
So
So
Yes, sir.
now, yeah, we have completed this chapter, and we have practiced nearly all the questions from this. So are you having any more doubt from this chapter?
Oh, sir.
Sir.
no, sir.
Okay, for example, okay, let me give one more example of a catalyst. For example, if it is this ammonia, we are reacting it with oxygen. What we get here?
Nitrite plus hydrogen.
Nitric oxide and water.
Okay, sir.
Can you balance this?
Sir, 2 NO. No way. It's already bad. No, it's not bad.
No. So you have to put
Okay,
2
if I
over
will write,
there and 3 at
Two
H2O. So 3 at H2O. 3 at H2O.
so is it now
Yes,
balanced?
sir. Yes, sir.
No, it's yet not
Wait,
balanced.
wait.
Not balanced.
2
Sir,
N.
5 by
Wait.
2 O2. 5 by 2 O2. And then multiply everything by 2.
Yeah, you can
5 by
write
2
5
O2,
by,
sir.
exactly, you can write 5 by 2 O2, but you have to remove this fraction. So you can just write like
Yes,
So
this.
you have to
You-
multiply it
Multiply everything by 2.
by
Like
yeah, you
4
have to
and
multiply it
X3
by 2.
plus
So you will write 4 times.
5O2 to
gives
4NO plus
6
6H2O.
Exactly.
Yes,
Now
sir.
here the catalyst which is used, that is the platinum.
Platinum used to be very famous.
Got it? Platinum is here used as a catalyst.
Sir.
Now
So
can you tell me
platinum is not much reactive, right? Sir?
exactly? Platinum is not
That's
much
why they
reactive, but
use
it, that is why we are using here it as a catalyst. It actually provides the surface area. More the surface area, more will this oxygen and ammonia react with each other. So that means it will increase the rate of reaction. Got it?
Yes, sir.
Yes.
Yes, sir.
Okay. Okay, now if it is reaction is just like this, that it is the carbon, it is the oxygen, it gives you the carbon dioxide. You have to tell me what is the total mass of reactants here. So can you tell me the total mass of reactants?
It's 12 into 16. Since it's one second, sir.
16 into 2, that is 32, 32 and 12.
44.
Exactly, 44. So what is the total mass of products? It's also you are 44. So that means total mass of reactants is always equal to the total mass of products.
Yes, sir.
Are you getting?
Yes,
Yes.
sir.
Sir.
Now there is question for you. There is question for you. Can you tell me the name of few metals which do not react with water?
Sir,
What react?
does iron react with?
Iron doesn't react with water.
Metals which iron will react with steam. That means when we just heat and react it with steam. Steam means water at high temperature.
Magnesium doesn't react with
Metals which do not react with water. So which will
Sir,
not
lithium. Lithium.
No, lithium is highly reactive. It's the
lithium
most
and
reactive.
potassium, they are highly reactive. They will easily react. Having these inner,
It's the cobalt.
yes,
Sir,
platinum,
won't react.
copper,
platinum,
Lead.
gold.
Lead.
yeah, lead. We are having
Lead.
gold, isn't it? They
Silver.
will not. Yeah,
Silver.
silver. They will not react.
Cobalt.
Sir,
Exactly.
Silver, sir.
magnesium.
Magnesium will
The
react, but
magnesium is reactive.
yeah,
It's a cobalt.
Sir, lead.
yes, lead will
Cobalt
also
is
not
not
react.
It's a cobalt.
Yeah, cobalt, etc. You can write the various examples. So I have just written here. So have you written down? Have you written down this?
Yes, sir.
Yes, sir.
Yes, sir.
Shall I move to the next page?
1 second, sir.
Yes, sir.
Okay.
Sir, can you hear me?
Yeah, I can hear you.
Can't hear you.
Okay, okay.
Yes, sir. Done, sir.
Okay, so now let me write here that if I'm having this silver nitrate, it also undergoes the photochemical reaction.
Yes, sir.
We are using the, okay, silver nitrate, silver bromide, silver chloride, they undergo photochemical reactions. I hope you remember these, right?
Yes, sir. Yes, sir.
Okay, now can you tell me the molecular mass of this ammonium carbonate? That's NH4 whole twice CO2, CO3. Molecular mass you have, molecular mass you have to calculate.
Okay, sir.
So it is now, see it how to calculate. It is nitrogen.
Sir, don't
It is
say, sir.
two.
Don't say, don't say.
Okay,
Sir,
okay,
don't
okay,
say.
Yes, sir.
okay, okay. Just calculate.
Sir, will it become 4 into 2 or will it just be like 6?
Yes, it will become 4 into 2. That means mass of hydrogen here it will be 8.
Yes, sir.
So is the answer 94?
Will it be 94 or 96?
Oh, 96. Oh my god. I know 6 instead of 8. Sir.
It's
It
96,
is
sir.
96, sir.
Yeah, I got
Exactly,
it
it will
96.
exactly 96 gram per mole. So I hope that you can now calculate the molecular mass of any substance if it is given to you, isn't it?
Yes,
Sir,
sir.
96
Yes, sir.
grams, sir.
Gram per mole,
Yeah.
yeah, it is the unit, gram per mole. It is the unit of molecular mass or molar mass.
96
no
grams per molecule.
No,
Mole.
mole.
Okay,
No,
okay,
see,
okay. I was like,
I will write it
okay.
here. You can write either 96 EMU, that is the atomic mass unit, or you can write 96 U, that is the unified mass.
So yes,
But
sorry.
yeah, but if it is the molar mass, then the unit, exact
Quantity
unit, that
matter.
yeah, that is the gram per mole.
Yes,
What
sir.
is
Yes, sir.
quantity matter, right?
Yes, I got it, sir. I thought it was
Okay,
like per molecule.
yeah, exactly. So now we have just completed this chapter, and I hope that you can now balance any type of reaction, and you can also calculate the molecular mass, and you can also tell the type of reaction also, isn't it?
Yes, sir.
Yeah, so we have just completed this chapter, and I hope that you can easily now face the exam. So wish you all the very best. Have a nice day ahead.
Thank you,
Yes,
sir.
sir.
Bye, sir.
Thank you,